So the way this presentation is going to work is I'm going to start at a very zoomed out level, and I'm going to sort of slowly get more and more detailed and, into the nitty gritty, as it were. So if at first it seems like I'm just doing broad strokes, we'll get there. That being said, feel free to ask questions, and I'll let you know if it's just going to be in the next slide or not. So I'll give you a little outline of what this is going to be. It's sort of going to be two parts. First, I'm going to do the overview. This is kind of like the, not sales pitch, but like a marketing presentation of what gears are and what you use them for. And then we can go into some of the fundamentals, technical aspects of actually building a gear. So I actually don't know what experience you guys have with gears already. Not really that important. I'm going to go through this anyway, but just bear with me if this feels like something you've heard before. So let's start at the very, very beginning. What is a gear? A gear is just what we call any sort of application or script or program that you run on our platform to process your data. A gear is composed of really three different sections. There's your algorithm, and that's the part that you really have ownership on, and you've developed and you've written. There's the dependencies, and this is going to be in the form of a Docker file. So I'll talk all about that later, but if you're familiar with Docker, you know a bit of the headache that's coming your way. And then there's Flywheel specific files. These are files that basically what you're going to do is you're going to create a Docker file, which if you're not familiar with is basically a very, very lightweight virtual machine. It's going to have all the libraries needed to run your algorithm. Eventually, you'll make it so that your algorithm does run on that Docker image. And then there's a couple files you need that sort of tell Flywheel what pieces of data to feed into that Docker file, and what configuration settings you might have and things like that. And the whole purpose of this is that once you've containerized your algorithm and developed this Docker file, anyone can run it on Flywheel. So this makes collaboration very easy. You're never again have to worry about your coworker having a Mac and you having Linux and libraries and all that stuff. It's just going to work now once you get it working on Flywheel. This means that it's reliable, it's reproducible. Some of you might be aware that I think there's issues with FreeSurfer where depending on the kernel that your operating system uses, volume estimates can be slightly different. So there are weird problems like that this addresses. And yeah, it makes collaboration extremely easy, just in the way you can share your algorithm. So why would you build a gear? I guess because you need to build gears to process your data on Flywheel. Of course, you can process your data on your own, on your machine. But if you're already utilizing Flywheel, you don't want to be downloading data, processing, uploading constantly. That's extremely tedious. The other thing is that gears are going to force you to be more organized than you may already be right now. What this means is that we enforce a couple things like strict versioning, and your older versions don't disappear. So if you're iterating through different versions of code and you process everything one way and then you read another paper and you realize that there's a better way to do the algorithm, you update your code, redo the analysis, send it to Flywheel. Flywheel will make you increment the version of your gear. It will store the old version of your gear so that if you want to go back and check your results, you're not, desperately searching through, hundreds of scripts on your computer looking for, version 2 and trying to remember which one you did or used for your previous analysis. And there's provenance as well. So you can look at the analysis that you've done previously, the outputs of old gears that you've run, and you can see exactly what gear you ran, what gear version you ran, what inputs there were, what your configuration settings were. It takes all the guesswork out of going back and, if you're trying to write your paper and do your methods section, it takes all the guesswork out of what you actually did. You have exactly the analysis that you went with. We have a couple rule-based or a couple automation tricks. We call these gear rules. one of the most common uses of gear rules is to automate basic pre-processing that you do to every single piece of imaging data that comes into your system. So, for example, typically people run something called the DICOM classifier, and what this does is it reads DICOM headers, tries to assign a classification, meaning, is this functional, T1, T2, behavioral, what is this image exactly? And it takes the DICOM headers and puts them in a Flywheel metadata format that you can now easily search on the platform. Sometimes people then run a DICOM to Nifty conversion, so you get all your files in Nifty. You can then, run a motion correction or something. And you can set up rules where that, yes, if it's a Nifty file and it's a functional bold classification, then run motion correction, so it's not going to try to do it on your T1s or anything. So this takes a lot of the grunt work out of, just getting your data set in a state that is usable. I've already mentioned sharing briefly. Once you have a gear, you can, I'll talk about the exchange a little bit later. There is a way for you to share gears with everyone who uses Flywheel. But beyond that, it's very easy for you to share your code that you use to make your gear with another user on a Flywheel platform. And they could upload your gear right to their site and do the exact same analysis. The other thing is our gears run on depending a little bit on your instance, but in general, they run on a cloud server. So there's scalability here, meaning you're not limited to your laptop or whatever resources. Some labs do have large clusters that they can work on, but you'll essentially be able to, again, depending on your instance exactly, but there's the potential for you to run hundreds of very large jobs in parallel. Multiple users can process multiple sets of data. It's not like you're limited to just one job at a time. We can scale up and give you the resources that you need. So those are sort of the main reasons why you would actually want to go about doing this. So this is a sort of brief little aside that I mentioned about sharing. Well, it's not little. This is a very large piece of our product. We have something called the Gear Exchange. You're not going to be stuck from scratch building every single processing step that you want to do. We have something called the Gear Exchange, which is essentially a library of pre-made gears. Some of these gears are made by us. Some of these gears are made by customers. If you develop a gear that the imaging community you think would really benefit from and you want to share with them, we can have it on our Gear Exchange. And this is something that all the users can search and install onto their instances. So this would be a great way to get your algorithm out there if you wanted to. I've already talked about this. And one of the ideals that we really hold dear here is transparency. We want people's scientific methods to be transparent. Reproducibility, as I'm sure many of you know, is a bit of a problem in some modern scientific areas. We're hoping to try to help address some of those concerns by keeping everything open source, transparent, keeping these logs of what's been run, keeping people accountable and, transparent about everything that they're doing. Reproducibility, there we go. All right, so.
Sorry, quick question. So
Sure.
Does it mean when we create a gear, it would always go in the open source, or we can have our own?
No, of course we know that there are some concerns about proprietary algorithms and intellectual property and things like that. You, of course, can keep your code private and simply I will talk about this a little bit later, but there is a way to just from your computer upload the data to Flywheel, your Flywheel instance. And essentially, people would not have access to the source code then. They would be able to run the gear if they're on your instance, but they would not be able to download and look at it, unless, of course, you share the code with them.
Okay.
Right, so that was sort of the overview of what a gear is. We're going to start to... We're going to turn up the magnification a little bit and start to get a little bit more involved into the technicalities here. So this is actually a perfect time if anyone had any questions about what I just asked to ask. Okay, I will continue then. So, what actually is a gear? What makes up a gear? I mentioned briefly sort of the three components, the algorithm, the dependencies, and the flywheel files. Now I will talk a little bit about what those are exactly. So these gear files, these are the, this is the algorithm that, you will write, and the manifest. And the manifest is sort of the flywheel side of the gear. The manifest is a JSON file that will talk to Flywheel and figure out what data to pull in. It will also it'll generate a user interface on the site. If you've ever seen a gear and you want to run it and it asks you for input and configuration settings, that's generated by the manifest. So when you create your gear, you create a manifest and you specify what options the user has. Your run script, this is usually a wrapper for your algorithm. So typically you've developed an algorithm and it runs on your computer, and typically to get it to work in Flywheel, you just need an extra run script, as we call it, which utilizes the specific file architecture of the Flywheel environment. When you tell the gear that you're using an input file, where is that file actually located in your Docker image? The run script takes care of all that and gets the files to the right place so that your algorithm can actually run on it. And then there's the Docker image. So let me ask you guys: have anyone here used Docker before, or any sort of containering? I don't remember what the other one is, but anyone? No Docker.
I have.
Yeah.
Yeah.
I
Okay.
think most of us have used Docker a bit.
Okay, that's good. Docker, I find, is one of the biggest stumbling blocks for someone who otherwise is, good at programming in Python or Bash or whatever, or R. They will struggle with the Docker side of things. So if you are unfamiliar with it, we have resources, but I would also recommend, if you know anyone who has experience, send them an email, ask for help or something. The dependencies can be very tricky. Sometimes I find what happens when I'm working with a client is, they have such a tangled mess of libraries on their computer. It's difficult to sort out what you actually need and how you actually need to set it up. So if you code with that in mind and you use things like virtual environments and you keep your dependencies clean and things like that, this step might be a little easier for you. And in general, if you're a lab, you can usually make a base Docker image. A lab typically uses the same sets of resources, of software resources over and over, right? FSL, AFNI, FreeSurfer, SPM, and you can create a base Docker image with all of those applications on it, and you can just develop your code and basically reuse the same Docker image with minor modifications. So it's not all doom and gloom. Okay. So a gear is made up of these gear files and the Docker image. You can either upload this directly to the Flywheel site yourself, or it can go to the Flywheel Gear Exchange, in which case anyone can upload it to their Flywheel site. The Flywheel site takes your gear, looks at the manifest. That allows it to generate a user interface and allows you to select inputs. It allows you to specify configuration settings. It runs the gear on an engine. It sends all of this to an engine, which is, on the cloud. It's basically, again, another little virtual machine that we spin up. We give it resources, and we monitor its health, basically, to make sure it hasn't crashed. The gear runs. It saves some output, and that output is pumped back to Flywheel in one of two different locations, which I'll talk about in a minute. And we have a couple tools. I'm not really going to talk about this here because it's more nitty-gritty than we need to get. But there is a very basic gear builder in the CLI that basically just gives you a template manifest run script and Docker image. It doesn't really help you do much else, but it's good for starting off. Okay, so let's zoom in a little bit more here.
I got a quick question for you if you have a second.
Absolutely.
So could you go to the previous slide?
Yes.
So here you show how you spin a gear, it just goes into an engine, which, as you said, is a small virtual machine. Do we get to select the specs of that virtual machine? If I wanted to have a GPU or not the GPU, that's the point, right?
Yeah. All right. So
is that something you will cover? Because if so, I'll just shut up and listen.
No, it's not covered in this. So, Sina, if you know better about this than I do, please jump in. But yeah.
Happy to cover that. So basically, right now, you would need to tell us what type of VM configuration you want, and in the back end, we will go ahead and configure that for you. You'd, for instance, say gear A needs this configuration, and we'll assign it. Where we're going, I think, by end of this year, maybe even earlier, I'm not sure about the timing, but I saw it on the roadmap, is exactly that. You would be able to either specify that in the manifest, which I think, David, you know about the Gear version 3.
Yeah.
Or during the runtime, when you're actually about to run your gear, there is a tag that you could define, and that would basically could get attached to your type of VM configuration, the size such as CPU and RAM you would need along with GPU. So there's going to be a couple of different ways to do that, but we're just not there yet, but we would be able to configure that for you.
That makes that answers. Thank you.
Yep.
Great. Any other questions on this? All right. So like I said, let's dig in a little bit more here. This has sort of already been covered, but sort of to walk you through as a developer, what steps do you need to think about when you're developing gear? There's really 3 steps to it. The first one is containerize. We typically do our gears with Python. This is pretty easy because you don't need to compile Python code. And you can there are plenty of tools available for managing Python libraries. Basically, what I'm trying to say here is, if you can, please use Python. It's the language that we speak the most here, and we find it very easy to maintain. However, we have plenty of users who use MATLAB. Some users who use C++. Others code exclusively in Bash. There's no limitation really, other than what Docker can and cannot support. So MATLAB just requires an extra step. If anyone here has coded with MATLAB and used the MATLAB compiler runtime, you know that there can be some hiccups along the way there. One sticking point here is that if you program MATLAB on Windows and you compile in Windows, you can't run that on a container then, because the MATLAB containers or the Docker containers really are only Linux that are supported on Flywheel right now. And a limitation of the MATLAB compiler is that it can only be run on the operating system that it's compiled in. So some things to think about. It's basically just, it comes down to the thing that you're using, though. There's no such limitation like that with Python or Bash or C or whatever. So
yeah. Hey David, I have one question here. So for us, when we're using MATLAB, we're using the central control license server. So does that mean we will have some trouble if we try to build the MATLAB some kind of to be a container? So like a communication with the license server. Is there any limitation? No.
So here's the way this will work. Has anyone here compiled MATLAB code?
Yes.
Okay. So once it's compiled, you might be aware of this or not. Once it's compiled, it actually no longer needs that license communication. You need the license, to run it, to compile it in the first place. But then once it's compiled, it can run on something called the MATLAB compiler runtime. That's a separate executable, or not executable. It's a separate library that you download from their website that you would then install in the Docker image or any computer, really. And it should, in theory, be able to run the script that you compiled. So short answer, no, not a problem. Once you get it compiled, it's good to go.
Okay, thanks.
Okay, so that's the first step that you should be thinking about when you're creating a gear. Containerize. What libraries do I need? What dependencies do I need? You know, there's space considerations. So if you've ever installed FreeSurfer, you know that can take quite a while. If you're not using FreeSurfer, don't put it on your Docker image. It'll take up 20 gigabytes and it'll add 30 minutes to your, Docker generation time. So then there's the testing phase, and sometimes it can be a little tricky to have an algorithm that's working on your computer but not working in Flywheel, and figuring out how to debug that, because the algorithm works. The problem is just somewhere in that interface from Flywheel to your code. It could be the manifest, it could be the run script, it could be a Docker image. We have a couple tools to help you do this. Our command line interface has something called Flywheel Gear Local. This will simulate a Flywheel Gear run on your local machine, which is useful as long as your Docker image or your gear doesn't take up too much space. There are plenty of gears that take advantage of the scalability of the cloud and end up using hundreds of gigabytes of memory. I can't test those on my machine, right? You can also do native Docker runs. If you're familiar with Docker, you can actually just run the image on your local machine. Again, there's sort of the same problem there of how many resources do you need? And but in general, you can usually come up with some sort of test to make sure the basics are working. And now here, this is the installation part. Once you've gotten everything working and you're ready to get it to Flywheel, you have to install it on your instance. So there's two ways. The public way, which I mentioned, and we encourage this for whatever you can possibly reasonably do. Have a GitHub repository with everything anyone would need to generate the gear themselves. You can send it to the exchange. We will add it so that it's searchable. And yeah, the source code's out there, the Docker hub's out there, everything you need is out there. And anyone can add it to their instance. And then there's the private way. This is with the CLI. You would do Flywheel Gear upload in the directory that contains your gear. It's private. No one else can see it, except for as a gear on your instance that they could run. And keep in mind that we do the logs are there, they're present. So if you're logging, proprietary information, that don't. If it needs to be secret, don't do that. But yeah, the source code itself will be hidden. Okay, so another thing you might want to think about when you're developing a gear is what kind of gear is this? And we really have two kinds. There's a utility gear and there's analysis gear. You'll see this nomenclature going around. We call utility gears converters, quality analysis, or classifiers. It's really just like a label to help keep things organized, but these three are all utility gears. These are good ways to think of, what would my gear be a good candidate for a utility gear if it covers any of these things: basic reconstruction, conversion, like DICOM to Nifty, that kind of thing, quality assurance, like MRI QC, or just classifying, which is the DICOM classifier. Like I said, looking at metadata tags to try to set Flywheel classifications for your image. The difference between these two types of gears, quality or utility and analysis, is where the output is saved. So if you think of an acquisition and you have a file in your acquisition, the output of utility gears get added to that acquisition. So for example, if we started off with this DICOM and we ran a DICOM to Nifty converter as a utility gear, now we would also get the Nifty file here, right in the same acquisition. And if we ran a quality control, some sort of, I'm not sure what this would be, maybe, a montage of images that we can briefly scroll through to check the quality of, if that's a utility gear, it also shows up right here. You can imagine that if you have a more technical analysis where you're going to be making hundreds of statistical output files, you don't want those all here. It would, basically make your session unnavigatable from the user interface. So you would want to make those analysis gears. An analysis gear creates something called an analysis container. And you have a separate tab on Flywheel when you're looking at your sessions that you can go to, and it's called Analyses, and it'll list all the gears that have been run. For example, this is FreeSurfer Recon All. And then you'll be able to look at these different pieces of information about this gear. Here are the results. This is the input file we provided. Here are the output files it saved. Notes, these would be if you wanted to add any. Gear configuration, these would be the configuration settings that you had for the gear. And logs, of course, you could view those as well. You can run an analysis gear at any level, project, subject, or session. What this really means ultimately is it determines where this analysis is saved. So subjects can have an analysis, sessions can have an analysis, projects can have an analysis. It doesn't mean that if I try to run FreeSurfer Recon All at the project level, it doesn't mean that Flywheel will automatically run it on every single thing in the project. That's not what that means. You can build your gear to do that, but it has to be an intentional design decision. So really, it's more just about, if it's about you deciding, what kind of gear am I running? Should it be on the subject? Should it be on the session? Or should it be on the project? If you have a group level analysis gear, you would run it on the project. It would have some logic inside to operate based on that. Yes, so this is what I'm saying, discrete analysis object. And every run of the gear will create a new analysis object as well. So if you rerun this 10 times, you'll end up with 10 analyses. Yeah, just to keep in mind. Okay, continuing. So I have talked about these things before, the Docker file, all these things. Now we're going to have to dive into what exactly are the implications of using a Docker file. Well, and using a gear. And the first thing that the first consideration is my algorithm even a good candidate to be turned into a gear? And what I mean by that is there's no opportunity in the processing pipeline for the user to input or modify, any settings. So if you have an algorithm that requires the user to come in and just like a FreeSurfer Recon All, do they want to go in and manually resegment some sections? There's no opportunity in the gears pipeline to do that. It should be able to run headless without any sort of intervention. There's no GUI. It's all going to be through config options that you specify when you run the gear. So anything that can be basically called from the command line is a good option. And then the dev environment as well. If you have a lot of dependencies that don't exist for a Docker supported operating system, then that might be very difficult to make a gear. Let's see. Oh yes, and just a side note, if you are going to be doing gear building and gear uploading, you're going to need site admin or developer roles on your instance. So that's something to keep in mind. And we do have plenty of documentation. The Flywheel Gear spec goes over all the things that I'm talking about here. The structure of gears, the structures of manifests, types of inputs that are valid, things like that. All right. So once you've identified an algorithm that's a good candidate, no GUI, standalone, all the libraries are Linux supported and all that, you're going to get down into the building blocks of your gear. So the manifest, the elusive manifest that I've mentioned now a number of times. This does describe the gear, the inputs, the configuration. It will generate that user interface when you're on your Flywheel instance and you go to run the gear. It's written in JSON. If you don't know JSON, you will have to brush up on it to really understand what's going on here. And we, of course, have a manifest schema that you should brush up on as well, that basically goes over the valid input options and the items that you need present in the manifest for your gear to even run. The run script, I mentioned this, wraps the core algorithm, brings the manifest and configure environment to the core. I'll explain that a little bit more later, and the Docker file, of course. Okay, not to be repetitive, sorry. Now, These three you have to provide. When you run your gear on Flywheel, there's also going to be a fourth file created called config.json. And this is Flywheel taking all the configuration settings that you set, all the input files that you set, and passing them in to the gear engine now that's running, that the gear should read and basically, set up the correct calls from. Now, this file is saved. Oops, let me just go back real quick. No, there's no way to go back. Hang on a second. There we go. That's the problem with animation. All right. This file is present on the actual image itself. So in your run script, you could open this, if you want to go in Python and do a JSON decode. You could load this, decode it. You could get your config options. You can get your input options. We also have a number of tools called the Flywheel Python SDK. The Gear Toolkit is another thing that we've developed that basically automatically loads this config.json and provides you with some useful libraries to quickly access the inputs, the configuration parameters, and things like that, which I can discuss a little later. And of course, we have documentation for. So,
quick question.
Yes.
Before if I heard correctly, you said that we need the Linux compatible library files. Is that true? I mean, if we have something that's on Windows, can we use it or we can't use it?
Well, the issue comes down to what Docker images are supported by Flywheel. So, when you say Windows, if you're talking about MATLAB on Windows or if you're talking about Python on Windows, yeah, sure, you can write your code on Windows, and then it should just be able to run in a Linux Docker environment. If you're talking about executable files, then I believe we will have issues trying to get that to work. Sino, we were just talking about this actually, right? Windows on Docker files, that's not supported?
Yeah, that is sort of something we need to work on, and it was intentionally left out, out of the contract for the first year. I believe it is going to be within the scope, within the second year of the contract.
Okay. Yeah, I mean, I was talking about the executables of Windows. So, okay, thank you.
Yeah, those might be difficult. But if you can possibly find, many of these softwares are released for Windows, Mac, Linux. If you can find the release for Linux, we might be able to help you get that up and running.
Yeah, just a little bit more. So I noticed when we try to work on macOS, we can use the one to run the Windows executable. So do you see any experience or any customer try to do that as an alternative path?
I have not seen any customers using Windows executables. Have you seen a?
Nope, I haven't either. Just because we really do not support that at this point.
Okay.
All right. Yeah. Well, yeah. Setting up Docker files is a lot of fun. I can only imagine it would be worse as with Windows actually. Okay, so I mentioned that the gear is running on an engine in Flywheel. That engine, of course, has a file structure to it. And the way Flywheel gets your input files and your configuration settings into that gear that's running on the engine is essentially with this file structure here. So let's go over the different pieces. Everything starts in this Flywheel v0 directory. And from here, we have the config.json that is generated by Flywheel when you select your configuration settings and your input settings and you click Run Gear. And you have an input folder. Just go through, yes, and you have an input folder. So any input files that you're working on, images, text files, anything like that, will go in here. Now, when you create an input in the manifest, you have to give it a name. So if you were to create two inputs, one named DICOM and one named JSON template, Flywheel would create these folders with that same name, and it would put the file that you selected in that directory. So that's pretty straightforward. Gears can take multiple inputs, as many inputs as you can put in the manifest. It can take. Can get a little tedious, but and inputs can be optional. So you can specify, if you only need a T1, but if you also have a T2, that's great. You can specify the T1 is mandatory, the T2 is optional. So there are some tools to make these algorithms very flexible. And then there's an output directory. Now, there are a couple things to note about this. Any files or folders present in the output directory will be re-uploaded to Flywheel into your analysis container. However, Flywheel does not support nested directories in the analysis containers. What that means is that if you have 3 folders in the output of your algorithm, and each of them has 10 files, and you just save those 3 folders in output, you're not going to see the 3 folders. You're going to see 30 unorganized files in your output directory. It flattens everything. What we recommend doing in that case is, this would be another function of the run script. You should zip your files, essentially. So one way to do that would be, you could zip all 3. So folder 1, folder 2, folder 3, create 3 zip files. You'll see the 3 zip files as your output, or you could just bundle it all together in output.zip. And then you'll just have 1 zip file in the output. A lot of things that people do is they'll zip up most of the files and just leave out a couple key reports, like if there's an error log or an HTML report, or just a couple little things like that you would want to click on quickly to see how you're, the details of what happened during the processing. That's a popular option, but you just don't want too many files in here. And in fact, there have been Gears where by accident they've had tens of thousands of files in the output directory, and that actually causes the gear to fail because of some timeout issues when re-uploading to Flywheel. So do be careful with that.
I have a question about the input.
Sure.
So I noticed when we're uploading DICOM files that it seems that it automatically zips all of them. So if I have a gear based on a Python routine that is expecting to read in a DICOM, will that work the same way, or do I have to add something into the Python to first unzip the file? Will it get it as a zip file instead of a DICOM, or does that happen automatically?
Okay, actually, I will be honest. I didn't realize that we automatically zipped DICOMs when they went in.
Maybe it was just how I uploaded it.
Possibly.
No, but it's also on your presentation, input image DICOM zip.
Well, we do zip a lot of them normally, I think.
Yes. So yeah, if I may add a little color to
Yes.
that. We do zip up DICOM files, as Faye can tell you. I guess there's really two reasons behind that. One is to save on the storage. As you can imagine, it saves like around 40% once you zip those DICOM files. And aesthetically, it doesn't overwhelm the UI because, each slice will get its own DICOM image. And before you know it, your UI will be overrun by thousands of DICOM files. But the advantage of zipping is, the other advantage is that, yes, you could in your Python file script unzip it, but we do have an SDK to where you can access individual member zip files. So you don't really need to unzip the entire thing to access all these. You can just access them without unzipping. Does that make sense? I'm not sure, David, you've done that before. But...
Yeah, actually, it's a handy feature, definitely. So it would essentially let you extract a single file from that zipped archive. And let's see. So I guess in answer to your question, yes, you would need to unzip it, unless the program that you're running, can handle zips. It may already have something built in. I think it's fairly common for people to have zipped DICOM archives. But yes, you would need to take that into account then.
Another thing is, I guess the purpose also matters, why you plan on unzipping. First off, we have automatic gears, as David touched on, where it automatically extracts all those DICOM tags and attaches it as metadata. So that's already available. So you don't really need to unzip and parse out all those DICOM tags. Secondly, if you do need the image itself, what we have done in the past or do actively is conversion of these DICOM files to Nifty format, where it's a lot less overhead, takes less storage, much quicker to load this data. So you can just load the Nifty files via your Python code and go about doing your routine analysis.
Yeah, don't unzip them in the UI. Leave them zipped there. Your run file could, if you need these unzipped, it could go through and unzip them, and then hopefully rezip them for the output. Just a bit of tidiness, I suppose. All right, I'll continue moving on then. This might not make a ton of sense right now unless you're familiar with the Flywheel metadata. Every file container thing on Flywheel has metadata. You can see it when you go to the object's info. You can write to that using this. If you save a .metadata.json file to the output directory, it will interpret that as metadata that should be added back to the analysis container, essentially. So there are also many tools in our SDK, our Python SDK specifically, that allow you to, and our API that allow you to modify the metadata directly. So many of our gears make heavy utilization of that. It's a very handy tool. Okay, so now I'm actually going to show you some things here. And I hope this is visible. I have an example I can show you guys after this if we have time. Just to sort of put some actual code to the screen now and show you what this looks like. This is an example of a manifest. And actually, I think, well, no, I'll continue to go through this. This is an example of a manifest. It's a JSON file broken up into a number of different sections here. Each section has different properties. The properties specify different things. This is all covered in our Flywheel Gear specification. Pretty much required reading. This generates that user interface for when you're running a gear, and it helps you get all the necessary parameters and inputs into the gear engine. So I'm just going to continue because this will sort of make more sense in a second here. There's a few key parts. There's the input parts. This maps to the Flywheel v0 input. So for example, here, this is a JSON object called inputs. Within it, we have a JSON object called Nifty. This means that it will end up creating a Nifty directory in the Flywheel v0 input folder. The description here is something that the user can see when they're setting up the gear for running to help them choose the right thing. Base, this tells Flywheel what it's looking for. We're looking for a file for this input, for example. We can specify what type of file, Nifty, zip, CSV, DICOM. There's a full list of, again, Flywheel Gear spec, check it out. There's a full list of files that we support. And what this really does is it just helps the user identify. It'll put a little arrow and highlight files that match these kinds. So it'll help you sort out what you're actually looking for. There's a config section of the manifest. This is basically the difference between config and input. It's all input to the gear. We reserve the term input for files. Any physical files that need to be copied in. Config is kind of like command line parameters, right? So if you want to set a threshold of some kind, or if you want to tell it the number of cores to use or something like that, anything that you would type in from the keyboard, essentially, you pass in as a config setting. There's a number of options here. We can set defaults, maximum minimums, types. We can set whether it's optional or not. It can be Booleans, it can be lists, it can be strings, many different options from the configuration to help you set up what you need for your gear. And let me show you what this ends up looking like. Yeah, the manifest maps directly to the run gear dialog. So there's a section up top with some information, the name of the gear, the version of the gear, a description of the gear, you know, some information on it. And this actually, when you select the gear from our drop-down menu, it will display the description and the version, and you can select from this drop-down list any previous versions. When you go to run the gear, then the inputs that you specify here will show up here as, you know, little input boxes, and you would click choose input, and it would show you your whole suite of data that you have for that project or that subject that you're working on, and you could select inputs from there. The configuration section will look a little different. Here are some of those, you know, these are true false buttons here. This is the fractional intensity threshold. It's a number text box here, and these little info square or circles, if you hover over them, it displays the description that you enter here. And these do support some amount of like you can put \n for new lines and tabs and things like that. All right. And all right, the run script. This again, most of the run script falls in your court, as it were. Basically, again, to think of it, it's the wrapper. So what it's going to do is it's going to, here, by the way, this is an example. This is not using our SDK or any of the tools that we developed that basically do this for you. But this is just demonstrating if you wanted to do sort of this manually, you can load the config.json file. You can get the config settings. If you're familiar with the JSON format, this makes sense to you. If not, learn about the JSON format until it does. You can get these different parameters from the JSON. You can get the input files. It's, you know, it's all pretty straightforward and readable. So once it gets the input file, it will pass it into the command that we're using here. And then there can be some cleanup at the end where you do some zipping and, you know, removing of any junk files that you don't want saved into the output, things like that. Yeah, and that's pretty much it. Parses the config, gets the input configuration options and files, takes the output, puts it in the correct format that you want. And that's pretty much it. So the manifest, let's see. Yeah, by default, it's looking for a file called run or run.py. You got to make sure it's executable. It can pretty much be anything, actually. We prefer to have your gears provide actual exit statuses, you know, 0 for success, anything else for not. This will help with the gear logs because you can go back and see easily if your gears failed or successful. Like, basically, if you say exit 0, no matter what here, as long as there's no, you know, no other exception that occurs in this code, if the gear sees exit status 0 here, it's going to say it's succeeded. So good to have checks here to make sure it's actually succeeded, or, you know, if failed, pass the appropriate value along. Yeah, so there's a couple here. These are just sort of leftovers that I'm trying to cover right now. The environment for the gear is a little tricky. Normally, you would develop an environment in the Docker file itself. Flywheel doesn't copy that environment over to the engine when you run it. So there's a couple things we can do. One trick we do is we save the environment as a JSON file in the Docker file, you know, to a directory, in this case, just cpack environment.json. And then in our run script, we can read that JSON, load it, and reset the environment. Another thing you can do is you can set this, and this is important to remember, things like path. You know, your path is not going to be present, which is going to cause all kinds of issues. Common source of problems. Just remember, environments are tricky. Another thing you can do is you can set the environment directly in the manifest. This is a little redundant because you really do need it in the Docker file, because otherwise it won't build correctly. Then you need to put it in your manifest. You know, we're working on this in Gears 3.0. We're trying to make this a better experience, but just letting you know that this is the way it is, and these are some options that you have. to get around it. This is probably the most recommended way, despite being a little bit more tedious. It's explicit, which means you don't have to worry about what's actually being set. And yeah, it just requires a bit of maintenance. Docker file. All right, for those of you who haven't seen it, this is a Docker file. It contains a series of commands that essentially build a computing environment. So we start from some source image. These are typically, if you go to Docker Hub, you can see all the different source images. This is NeuroDebian. You can do Ubuntu. You can do CentOS. You can do anything they have to offer up there. There's a few main commands that you'll use. Copy copies files from your local directory into the Docker file. Run runs a command, just like a command line command. So any apt-get or sudo yum install you'd need to do to get your algorithm working, you'd have to put in the Docker file. env sets the environment, but as I mentioned, this won't be carried over to the actual engine at the time of gear execution. Excuse me, just to keep that in mind. And yeah, here we copy in our run script, our manifest. These are essential to have in your gear. And we set an entry point. Again, something that's useful for Docker files, but unfortunately Flywheel ignores. There is something, let's see. The manifest can specify a command, which essentially takes the place of the entry point. And what that does is it tells the engine what script to run or what command to call as soon as you run the gear and the engine boots up. So that would usually be, you could call like Python 3.7 run.py or something. But the good thing about this is that once you get all your libraries and your environment set up, you can share this with anyone. They can build it, they can run your code, and it makes reproducibility a breeze. So I'm just going to give you a quick look at the config file, and I'm going to give you a little hint here. In your early stages of building gears, something I like to do is I like to copy in my run script. I'll copy config.json to the output directory. And that way, when the gear finishes, even if it's an error, anything in the output directory gets saved to Flywheel. So that gives me an extra little thing of debugging where I can physically look at this config file and see what options were passed in. And maybe I'm doing something wrong. Like maybe I'm calling location name when I should be calling location path or something like that. But this is typically what it looks like. It has the config setting. This matches the config section of the manifest. Any options like thresholds or input options that you could do from the keyboard. It has an input section, matches the manifest. Any inputs you specified there. Some information about it. Usually you're only interested in the location. This is where it is on the Docker image. This will pull in any Flywheel metadata, so you can access that if you want. Here's another input, MATLAB license code. Shouldn't need that unless there's some esoteric application for it. But yeah, so this contains all the information you need essentially to take the inputs and configuration settings and run your gear. That's actually the last slide. This one is just a repeat of this one because I thought it was a good one to end on if there are any questions. So that's it. And I understand that this was a very high level overview and we covered a lot and I probably went too fast. This is to get you familiar with the concepts so that when you try to read up on this and try to build your own gear, you're not, stuck on what is a manifest. You should have some idea of what that is now. Please read the documentation. We will share this with you. Reach out if you have any questions. We're happy to work with you guys. And yeah, good luck on your gear building. So any high level questions or anything you want me to go into more detail on?
Yeah, thank you.